Both sides in the chemical contrail debate agree that aviation fuel, like all engine fuels, contains harmful pollutants. However, only the chemtrail believers claim that secret additives in jet fuel are being used in weather modification experiments. Could scientists test a random sample and find high levels of aluminum oxide or other unexpected compounds and solve the case? We traveled to Flint, Michigan in search of the best evidence.
I'm a laboratory coordinator here for Kettering University. This is a small jet turbine. This device is a model of a larger jet. It functions just like a large jet engine does.
Best evidence has come to Kettering University to conduct a series of tests on commercial jet fuel with a team of experts in chemical and mechanical engineering, led by Dr. Greg Davis.
After I received the call from Best Evidence, I contacted Dr. Robert Gettner in our chemistry laboratory. Then I pulled together Mr. Ray Rust. He's the technician that runs the laboratory facility we're sitting in now. This is where we actually test the fuel and test the emissions that are produced.
The Kettering staff took about a week to shift the main facility from automotive engine testing to the jet turbine experiments. Sensitive equipment was tested and calibrated with a number of trial runs. Test day began with the purchase of 5 gallons of randomly selected commercial jet fuel from the local airport.
The jet engine we have in the lab is a scale model jet engine. It does everything that a commercial jet engine would do on an airliner. And it's got the added advantage that we're running it in a lab, so it's a controlled environment. So we can control the fuel that we feed it. We can draw the samples of the emissions.
Best Evidence has asked the scientists at Kettering to look for any traces of aluminum in both the liquid fuel as well as the emissions after it combusted in the jet engine. Aluminum appears to be the metal most often identified by people who believe there is a conspiracy to turn contrails into chemtrails.
That would seem surprising to me just because of the issues that engines like this have with throwing strange components into the fuel. So it seems like if there was aluminum in the fuel, you'd have trouble with the turbine, for example, or you'd end up with metal plating showing up in the exhaust port. So it seems that that would introduce some definite problems that the engine designer would have to take into account for in order to make the engine survive that.
While Ray Rust prepares the engine for its flightless journey using our sample of test fuel, Greg Davis selects the special quartz filters. They will capture samples of soot and particulate matter from the jet emission.
Right. So what I'm doing now is I've just placed the quartz filter element into the holder. It's in here. So I'll be doing that with both of those. Now the problem you run into with these is the amount of particulate you gather is relatively small. So things like fingerprints can actually skew your sample so much as to be unreadable. So that's why what we have to use are tweezers to touch the filter elements. That drives off any impurities.
Meanwhile, upstairs in the chemistry lab, Dr. Rob Gentner is preparing solutions to form the basis of several tests.
So what I have here is a test tube with isopropyl alcohol in it. I'm going to place a piece of aluminum metal in there. I will then add concentrated hydrochloric acid, which will mix with the isopropyl alcohol and start to react with the aluminum metal that's in there.
Sure. So it's reacting with the aluminum that's in the alcohol then, right?
Yes.
Okay.
So I've taken some of the jet fuel, which you gave to me. There's some isopropyl alcohol in here.
So if there's aluminum in here, we should see it start to bubble,
see
right?
The continuous evolution of hydrogen gas. Right now what we're seeing is a separation of the layers between these two.
It cleared right up though.
Yeah. There we see the 2 layers, but we have no evolution of hydrogen gas.
So at least in this sample, we don't have any aluminum.
In order to further test the jet fuel for aluminum, Drs. Gentner and Davis decide on a more rigorous experiment using an atomic absorption spectrometer.
Okay.
The machine can detect the presence of substances down to parts per million.
So what it allows you to do is it allows you to take unknown samples and compare those samples to see where they're similar and where they're different.
The 2 scientists will compare the jet fuel sample with a number of other solutions, including the closely related product, kerosene.
So then what we're going to do is put our fuel samples in here, draw it in through this tube, have it atomized, sprayed into the flame, and we're going to look to see if there's any absorption due to the aluminum that would be in the fuel.
Yes.
Down in the emissions test lab, Ray Rust has donned his protective headgear, turned on the ventilation system, and he's now ready to begin the experiment.
One of the major inputs into a jet engine, which has a major influence on the exhaust, is the air that you're pulling in. We have a much higher level of control here than you would out in the atmosphere. Our air isn't being contaminated by another jet that we happen to be following.
2 intake nozzles sample the jet engine emission at the exit port. One leads to the particulate filter. A second nozzle leads to an exhaust gas analyzer. As the equipment goes to work, upstairs in the chemistry lab, Drs. Davis and Gertner are about to test the liquid jet fuel in the atomic absorption spectrometer.
So what we're going to do then is we've got a light bulb that is essentially producing light or radiation that is going to be absorbed by a flame.
The jet fuel sample will be sucked up as a very fine mist and burned in the flame. If aluminum is present in our sample fuel, it will give off a warm color flame.
The lamp in here is producing radiation given off by essentially aluminum foil that's been excited.
This aluminum-treated solution indicates how our fuel sample should look if the metal is present.
Now, if there's any aluminum species dissolved in our samples, that aluminum will interact and absorb some of that radiation, so the output will be different than when there's no aluminum there.
With all the tests now complete in the chemistry and emissions labs, it's time to feed all the data into the computers.
We, calibrated our equipment. We used our best level research grade equipment. I mean, we used in this project probably between $1 million and $2 million worth of equipment for testing. So we tried to go at it using the objectivity of a scientist.
Will our tests for aluminum and jet fuel support the chemtrail believers' case? Or will the results create even more controversy? Next on Best Evidence.